Here we're going to go over some examples of problems where we have to simplify where there's more than one rule that we need to use. So when you need to use more than one rule, then you need to follow an order of operations. So in this case, if we look at it, we see that there are parentheses and an exponent outside of the parentheses right here. So that means we need to use the power rule. The power rule means that you are kind of distributing this. This is 3 to the second power, which is 9. And then with the power rule, you multiply the two exponents. So this is x to the 10th. And then this stays the same. Now you can multiply or divide. I see I have this x to the 10th and x to the 3rd. They have the same base. So what I can do is subtract the exponents. 10 minus 3 is 7. And then I have 9 sevenths. 9 27ths. I can simplify this fraction. Both of them can be divided by 9. So this is going to be 1/3. So there's that one. Let's go over another example. Sorry, it's kind of skipping ahead. All right, here's one. So for this one, I'm actually going to delete this little negative sign. Just take that out of the equation. And let's do this one. Again, I see that there is a parentheses with an exponent outside. So I'm going to use the power rule. So this is going to be, remember, you're multiplying the exponents. So the a's, 2 times 4 is 8. And then b, that's just b to the first power times 1 is 4, or times 4 is 4. And then the other a to the third power stays the same. So now we can multiply or divide, and I see that I have 2 that have the same base. These both have an a. So when you are multiplying, you are adding the exponents. So 8 plus 3 is 11. And then the b to the 4th, nothing changed there. It stays the same. So let's go over another one here. This one, I see that there's some adding, but I need to wait to do that until the very end. First thing I'm going to do is take care of these exponents that are outside of the parentheses. So again, I'm going to use that power rule. When I do that, this is going to be 4 to the negative second power. And then I multiply my exponents. X to the negative 6th and y to the negative 12th. And then the same over here. I have 2 to the negative 3rd power to start off with. And then when I multiply these with the power rule, this is x to the negative 6th and y to the negative 12th. So in this case, if I think about what 4 to the negative second power is, that is the same as 1 over 4 to the second power, which 4 to the second power is 1 over 16. So I just changed this number. And the same here. If something is to a negative power, you can change it to a fraction and just put it in the denominator and take the exponent off. So this is the same as 1/8. And if I would like, I can change these as well. You might notice they're the same exact thing. They also have negative exponents. So down under the denominator, I'm going to put that x to the 6th, y to the 12th. Or here, x to the 6th, y to the 12th. I put it down in the denominator, and I took off the negative sign. So this right here is what I need to simplify just a little bit more. Since they both have the same exponents and variables, this x to the 6, y to the 12, then I can combine these like terms. Just as if this happens to be, if this was 1/16 x plus 1/8 x, I could add these together and just see how many x's I have. That's the same as if it is 1/16 x to the 6, y to the 12 plus 1/8 x to the 6, y to the 12. So we want to think, how do I add 1/16 and 1/8? When you're adding fractions, they have to have the same denominator. So 1/16 plus 1/8. 1/8, I need to change that so it has maybe the denominator of 16. And I know if I multiply them both by 2, if I multiply 8 times 2, that's going to give me 16. So I can do that. You can multiply a fraction by the same number on the denominator and the numerator, and it's fine. It's like multiplying it by 1. And now I can add these together, and that's the same as 3/16. So knowing that, we now know that this in total is 3/16 x to the 6, y to the 12th. Let's see if there are any others to do. This one here, there's a lot of different numbers and exponents here for a, all with the a variables, so we can condense this. There's no parentheses with exponents on the outside, so we don't have to do that, but we do have some multiplying and dividing. I'm first going to multiply my numerators. So this right here, so 6 times 5 is 30, and when I'm multiplying the a's, in total, I'm going to add 3 plus 9, there's 12 a's. And then down here, I have negative 12 a to the 14th. Now, if I look at just the fraction, 30 over negative 12, I think, well, they can both be divided by 3, so that would be 10 over negative 4. I can still divide those by 2, so that would be 5 over negative 2. So I just simplified that fraction part a little bit. Now let's look at the a's. This is dividing. So remember, with dividing, we are subtracting the exponents. So it would be a to the 12 minus 14. So a to the negative 2. And the very last thing I can do, if I would like, I can change that a to the second power to be not have a negative exponent. So it would be 5. I have negative 2, and I'm going to put this a to the second power down here, and I take that negative sign off. So this actually is my more final answer right here. So again, with these, you want to follow order of operations. Just go step by step. Look at your notes to remember what each of the different rules are. And please let me know if you have questions.